Use the table of ratios for the right triangle ABC to answer the following questions. So we want to identify a set of potential lengths for the sides of triangle ABC and explain or show your work using the built-in Desmos calculator. So we're going to say that this angle up here is 75, which makes this angle down here 15 because they have to be complementary. And I'm just going to pick a length. So we'll say that this length is 1. Actually, you know what? We're going to say that the hypotenuse is 1. And this is just one possible solution. This is, somebody else could have come up with something totally different for this. But I'm going to say that AC is equal to 1. So if I want to figure out what AB and BC are, we'll call one of these X and we'll call one Y. So if I want to do, we'll say this angle right here, this becomes my opposite, this is the hypotenuse, and this is the adjacent. So if I want to figure out the opposite, I would do the sine of 75 is equal to the opposite divided by the hypotenuse. So sine of 75 is equal to, the opposite is x, and the hypotenuse is 1. Well, I know that this is my cosine, I know that this is my sine, and I know that this is my tangent. So really, I know that sine over 75 is equal to whatever I get here. So the sine of 75 would be 0.97. So this length here from B to C would be 0.97. Now, if my cosine, if I'm looking for my cosine, that would be the adjacent over the hypotenuse. Well, if I multiply both sides by 1, just like we did over here, just the cosine of 75 would be equal to y. Well, this is my cosine of 75, so this would be approximately 0.26. So on the next one, you can see our answers are right here. Now, identify a different set of potential distances for the sides of triangle ABC. Well, let's say that I wanted to change this to 10. So instead of it being 1, it would be 10. So basically all I'm doing is I'm taking that original triangle where this was the sine, the cosine, and the tangent, and I'm multiplying that triangle by 10. So what would happen is all of these would get multiplied by a factor of 10. So AB would be 2.6, BC would be 9.7, AC would be 10, because what we're doing is we're just changing this amount down here. So instead of multiplying the cosine of 75 times 1, we're multiplying the cosine of 71 times 10, multiplying the sine of 75 times 10. So for the last one, how are the two triangles that you identified in parts A and B related? Those two would be similar triangles because they both have the same two angles. Remember that only in order to show that two triangles are similar, we have to have two pairs of angles that are congruent. So those two triangles would be similar triangles.